Okay, we are reviewing chapter 3 and 4 in this video. We're going to estimate the sum or difference by rounding. 2.95 is close to 3, and 7.01 is close to 7, so 3 plus 7 is 10. 10.2, we're going to round to 10. 6.895 is close to 7, so 10 minus 7 is 3. 7.12, we're going to round to 7. 2.05, we're going to round to 2, and we have 14. With division, this is the only time that your rounding is a little different, because in division, what you want to do is find something that's easy to divide. So like here, 5.04 is close to 5. I need a number close to 19 that's evenly divisible by 5. And so I'm going to actually round that 19.28 up to 20. And that would give me that it's close to 4. Okay, 5 through 9, we're using this data. The first thing I ask you to do is order your data so that it's in smallest to greatest form. Calculate the mean. To do that, you have to add up your numbers. 3 plus 3 is 6, plus 6 is 12, plus 8 is 20. Carry my 2, I get 40. And then there were 5 terms, and that will go in 8 times. So my mean is 40. The median is the middle number, which in this case is 6. The mode is the number that appears the most often, which is 3. And 20 is an outlier. It's a term that's much larger or much smaller than all the others. What if you had a data set like this, and I ask you to find the median? When you go to find the median on this, your middle number is actually not a middle number. It's 4 and 6. So what you have to do is find the average of 4 and 6. Add them up and divide by 2. You get 5. Okay, here we have area equals base times height, where the base is 2 centimeters and the height is 3 centimeters. 2 times 3 is 6. Centimeters times centimeters is centimeters squared. Momentum, P equals mv, where m is 10 and v is 5. And so we're going to get 50. The units on this, which I know you're not familiar with, you just have to write the units down. They don't cancel or anything like that. And that's what it is. Here, we have plus 2.3, so we're going to subtract 2.3. Remember to line up your decimals. So we get 7 minus 3, write my decimal down, 5 minus 2, I get 3.4. On number 13, I need to add 4.24 to both sides. Again, remember, line up your decimal. So we get x equals 6 and 4 is 10, carry the 1, 8, and we get 5.80 or 5.8. On this one, I'm going to divide both sides by 2.5. So I take 7.5 divided by 2.5. I need to move my decimal one place. So I have 25 into 75, and that will go 3 times. I think 3/4 is 75 cents. On this one, I need to multiply both sides by 1.2. And I don't know how you want to show that. So we're going to end up with x, and then 1.2 times 11 is 1.3, or it's 13.2. Choose the appropriate metric unit. For distance between Greer and Columbia, we would use kilometers. For the mass of a pea, I would use milligrams. The mass of a human, I would use kilograms. The amount of fluid in a Coke, and I know I'm all over the place here. A can of Coke, I would use milliliters. The height of a human, meters. Amount of fluid in a pitcher of tea, I would use liters. And then here, you can either use dimensional analysis, which is what I'm going to use, or you can write out your units and move the decimal. It's kilo, hecto, deca, and then your base unit like grams, liters, whatever. Deci, centi, milli. I'll show you both ways. There are 1,000 millimeters in 1 meter. So that will cancel, and 1,000 times 2.5 just moves the decimal 3 places to the right. And how you would do that here would be you're going from the base to meters, so you would go 1, 2, 3 steps to the right, so you need to move the decimal 3 steps to the right. 725 grams to kilogram. There's 1,000 grams in 1 kilogram. And again, doing this, we go 1, 2, 3 steps to the left. 725 divided by 1,000 would move the decimal 3 steps to the left. Anytime you divide by a multiple of 10, all you do is move the decimal to the left. So if you divide by 10, you move it once to the left. If you divide by 100, there's 2 zeros, you move it twice to the left. If you divide by 1,000, you move it 3 times to the left. And if you're multiplying by factors of 10, like we did here, you move it to the right, however many zeros there are. Okay, our divisibility rules. It is divisible by 2 if it ends in 0, 2, 4, 6, or 8. It is divisible by 3 if the sum of the digits is divisible by 3. It's divisible by 5 if it ends in 0 or 5. It's divisible by 9 if you add up the digits and they're divisible by 9. And it's divisible by 10 if it ends in 0. So it ends in a 4, so it is divisible by 2. 3 plus 2 is 5 plus 4 is 9, which is divisible by 3 and 9. It is not divisible by 5 or 10. 20 is divisible by 2 because it ends in 0. 2 plus 0 is 2, so that's not divisible by 3 or 9. It ends in 0, so it's divisible by both 5 and 10. 111 is not divisible by 2, but the digits add up to 3, so it is divisible by 3 and nothing else. Here, do inside your parentheses first, then do your exponent. 3 squared is 9, and then do your subtraction. Here, do inside your parentheses first. 7 minus 5 is 2. 2 to the 4th is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. On this one, only the 2 is squared. This is negative, and then 2 times 2, which would be negative 4. On this one, the negative 2 is squared. So this is negative 2 times negative 2, which is positive 4. On this one, we're going to plug in our 3, replace our x with 3. Do my exponent first. 2 times 9. 3 squared is 9. 2 times 9 is 18. 18 minus 5 is 13. B squared, 3 squared, minus a negative 2. Replacing the a with negative 2. That's going to go ahead and become positive. 3 squared is 9, plus 2 would be 11. 23 is prime. 27 is divisible by 3 and 9, so it's composite. 76 is divisible by 2, so it's not prime, it's composite. So if it's divisible by anything, it's a composite number. Show your prime factorization, 2 and 10, and then 2 and 5. So we get 2 squared times 5. That's your answer. Here it's just 3 and 5, so your prime factorization are 3 and 5. For your greatest common factor, we list them differently. 2 times 2 times 5 for 20. I listed them out separately. And then for 15, it was 3 times 5. So now we have to find what they have in common, and they only have a 5 in common. Here, for 6x squared y cubed, 6 is 2 times 3. X squared would be x times x. Y cubed would look like that. 10xy squared. 10 is 2 times 5. I have the 1x and 2 y's. And now we'll go through and find what they have in common. They have a 2 in common. They have an x in common. and they have a y in common twice. So you end up with 2x, and then y times y would be y squared. Notice that we list them differently when we're finding greatest common factor than we do when we're finding least common multiple. Simplify the fraction 12 over 15, both multiples of 3. And so divide by 3 on the top, we would get 4. Divide by 3 on the bottom, we would get 15. On this one, the 8 and 12 are both multiples of 4. So that would give me 2/3. But what about the x and y? Well, x over x, that would reduce to just nothing. And then y squared divided by y, there would still be one y up top. Let me show you how that works using your prime factoring. So 8 is 2 cubed. 12 is 2 times 2 times 3. And now you can see I can cancel that 2 and that 2. The x will cancel, one of the y's will cancel. And so I end up with a 2 and a y on top and just a 3 on the bottom. Moving on to multiplying and dividing exponents. When we multiply exponents, we add the exponents. So that one has a 1 on it. So this is 2 cubed, which is 8. 2 times 2 times 2. 3 and negative 2 aren't common base. So we're just going to have to multiply those two together. We get negative 6. And then x squared and x cubed would be x to the 5th. Again, we add these exponents on our common base, which is an x. Here, we'll look at the m's first. That's going to be m to the 5th. And then look at our n's. We have n squared times n to the 1st, which would be n cubed. And the reason why that works is if you did this longhand, n squared is n times n, m cubed, there's m cubed, here's m squared, and then here's this n. So I have 5 m's, so m to the 5th, and then n cubed. 21 and 22 is power to power. When we raise a power to a power, we multiply. So 2 to the m squared to the 4th is m to the 8th. And again, the reason for that is because m squared to the 4th is this. It's m squared times itself 4 times. 2, 4, 6, 8. That's where that 8 came from. Here, the exponent on the x is a 1. So we're going to get x cubed y to the 6th, multiplying our exponents. 23 through 27, we're doing division. When we divide, we subtract our exponents. So this is going to be x to the 3rd, 4 minus 1. 9 divided by 3 is 3. X to the 5th divided by x cubed is x squared. 5 minus 3 is 2. This is going to be x to the 0, which is 1. And you can see that that's 1 because you have the same thing over the same thing. On this one, I have x squared over x to the 6. Looking at this longhand, this is what this looks like. 1, 2, 3, 4, 5, 6. And so you can see that and that will cancel, that and that will cancel, leaving me with a 1 in the numerator and x to the 4th in the denominator. That's how we write it using a fraction bar. Without using a fraction bar, we follow our rules and we subtract our exponents. 2 minus 6 is negative 4. So this is x to the negative 4. So these two things are actually two forms of showing the exact same thing. And then here, scientific notation, we find our first non-zero digit, which is a 1, and put the decimal right after it. So we want 1.57. 1,570 became 1.57. This got smaller. The exponent needs to get bigger. How much bigger? 3 times. Find your first non-zero digit. It's this 2. Put the decimal right after it. So the decimal is going to move 3 places to the right, and it's going to become 2.54. So if you look, this became 2.54. It got bigger. The exponent needs to get smaller by 3. So it's going to be 10 to the minus 3. If you move your decimal to the left, your exponent gets bigger. If you move your decimal to the right, your exponent gets smaller.